So let's talk about the origin of rock types. Now, you might be wondering, man, what is rocks? What do rocks have to do with a biblical view of the world? I mean, rocks are rocks, aren't they? You guys are constantly stubbing your toes over them wherever you walk, and your kids are interested in them. I've had more moms come up to me at these homeschool conventions telling me, look, I don't know what to do with my kids. They pick up these rocks, they stuff their pockets with these rocks, and they're all their special treasures. They end up in my dryer and a washing machine. What do I do with them? And this is a tremendous opportunity for you as a mother, for you to learn. And dads, I don't want to leave you out here, but it seems like primarily the mothers that really are burdened about this whole area for some reason. Dad's just kind of, yeah, whatever. So you go to the library and you pick out your books on rocks and minerals, crystals, dinosaurs. Every one of them come from an evolutionary perspective. And so the kids, right out of the blocks, taking a field of interest and enthusiasm they have, and we're corrupting it with all kinds of secular ideas. So I got tired of that and decided, okay, I'm going to write my own stuff. And so that's what Vicki and I have been doing for the last several years, is making sure that we leave a complete biblical geology curricula for people after my days are finished here. And that's a project we're aiming to finish here, hopefully soon. Okay, so rock types. Now, all rocks, regardless of the planet you're on, share the same basic components of elements and minerals. It's true for the moon, it's true for Mars, it's true wherever you go, unless the planet is totally a gas planet. But the rocks are virtually the same. The minerals are the same, the elements are the same, maybe in different quantities. But you're looking at the same basic components. Now, secular geologists look at this, and they come to this conclusion. These common components demonstrate that the Earth, as well as all the universe, came from one common evolutionary source and event, the Big Bang, roughly 13 to 15 billion years ago. And that's their conclusion, seeing the same things that we look at. We also call this view, if you don't want to just memorize everything I've got on this particular slide, here's another way to view this idea. Small and slow and long ago, I learned this from a biologist many, many years ago by the name of Gary Parker. And I thought, well, that is a very good synopsis of the evolutionary view of life and the earth. Small and slow and long ago. In other words, small incremental changes taking place over millions and millions and billions of years. That is a viewpoint. Now, creationists would look at these elements and minerals, and they would draw this conclusion. These common components demonstrate that the earth, as well as all of the universe, came from one common designer who spoke the universe into existence, the creation, 6,000 years ago. And you go, oh man, you're one of those crazy people that believe in 6,000-year-old earth. Yes, I do, but not because of science. I do because it's written primarily in Genesis chapter 5. Now, you guys are probably sitting there wondering, what is it about Genesis 5 that tells us this? Well, I'm going to leave that for you to go and study that out. It's one of the first chapters, though, we look at in all the classes that I teach, is looking at the age of the earth issue right up front. What does the Bible say about the age of the earth? And it does have a lot to say. It's written out there in front of God and everybody, very clear, and it is there. Now, this view we call big and fast and in the recent past. So creation was big, wasn't it? I mean, it happened. People will tell me, look, the Bible doesn't tell us how God created. Couldn't it have been done over millions and millions of years? Well, no, the Bible does precisely tell us how the universe was created. And it's written in the first chapter, it related ways of saying it somewhere around 20 times. He spoke, and it was. That's the process for a supernatural creation. He spoke, and it was. He spoke, and there it was. God said, let there be light. And after 13 billion years old, light developed into a point where we can, no. God said, let there be light, and there was light. So that's his process. He spoke the universe into existence, and he did it in a big way, and he did it fast, 7 days, and he did it in the recent past, 6,000 years ago. Now, when we embrace this and when we spout this, we are called science deniers. Have you ever been called a science denier? Anybody here? Called a science denier? Man, I'll tell you, you got to have some thick skin for that not to affect you. Science denier. Nobody wants to be called a science denier. And so what I want to do tonight is to take a look at one area where I think the scientists have got it wrong. And I can show you why. And this is the major area that I battled with right after I became a believer. And very, very simple ideas here. But I think what we're so used to doing is listening to the narrative of secular geology that when we hear anything that's contrary to it, woo, that's weird, it's strange, that's a horrible idea, don't go against the science. Well, I want to know, what am I going against? Am I going against science, or am I going against particular narratives? So those of you, I want you to think back now, okay, 3rd grade, 4th grade, maybe 8th grade, maybe you never learned this. I bet, though, as a mom, if any of you have taught your kids at home, you probably taught them this, that there are 3 rock types: igneous, metamorphic, and sedimentary. How many of you learned that and can remember that? Any of you? Most? Yeah, a lot of you can. You can remember it. I remember it: igneous, metamorphic, and sedimentary, 3 rock types. And now you look at these, and what our typical response is in learning rock types is to memorize them. This is when you take elementary geology in college, one of the final exams is, and you study it all semester. In the lab, the professor has a tray of rocks that he introduces to you at the beginning of the year. And they're all labeled. And he says, now here's your final exam. I will take the labels away, and I want you to identify the rocks. Oh, okay. Well, the key is just going in there several times and memorizing them. Isn't that right? Just memorize the rock and the label. What's it look like? Well, I began doing something a little bit mean. I would mix up the rocks so that I'd substitute rocks. Instead of them being these particular rocks that were on the tray, I do this with my students. I'll talk about these rocks, use these as my samples, and then I'll substitute other samples that are the same rock type, but they're a little bit different. Maybe they're a little bit different color, but the patterns in them are the same. And then I'll have them identify them. And it tells me very quickly whether they're learning the principles behind rock identification, rather than just simply memorizing the pictures. So it doesn't teach you anything. For you to memorize the pictures, you won't learn anything, because they're all different. In my own collection of volcanic rocks, for instance, I probably got 250 varieties of volcanic rocks. And I keep finding new ones all the time. But there are certain principles that I rely on to identify them. Now I'm getting into the science aspect of it. It has nothing to do with how old they are or are not. They have to do with different principles. So, 3 rock types. Now, here are the definitions that we learn in secular geology. First of all, igneous rocks. Now, the word igneous is from a Latin word that means fire. So, by this, we mean rocks that are formed from intense heat and melting, some of them over millions of years. This is what you're told. Metamorphic rocks, word metamorphic, it's actually a biblical word. It comes from Romans chapter 12. Do not be conformed to this present word, but be metamorphosed. Uses the Greek word there, by the renewing of your mind. So it's the word change. Now these are changed rocks in some way, but geologists teach that these are rocks that are formed from heat and pressure over millions of years deep underground. Okay, you got this so far. You memorizing these definitions as we go here? All right, and sedimentary rocks. We're taught that these are rocks that are formed from millions of years of sediment accumulation, layer upon layer. This is what Charles Lyell taught. This was the basis of modern geology called uniformitarianism in the late 1700s, early 1800s. It has to do with uniform processes and rates over millions and millions of years. And it's slow, small and slow and long ago. Now, these two guys are very interesting characters. You would think, wow, one of them, James Hutton, this first one, is called the father of modern geology. So he must have been pretty big wig in the geological field, you would think. Maybe he's going to have that kind of a title. He's got to know his geology. At least today, that's what we expect. And the second one over here is Charles Lyell. Now, he's called the White Knight of geology. That was his nickname, the White Knight of geology. And he's credited with saving geology from the religious bigots. And this is a character whose goal it was to stamp out any reference to Genesis when it came to studying Earth history. So these two guys are very interesting characters. I didn't know any of this stuff. When I was taught freshman geology about these two characters, I was taught they're really heroes. And so everything is just, it's glowing. Everything they put their hand to, it's magic. But James Hutton was one of the fathers of the Scottish Enlightenment. Now, you don't need to go very far to figure out that the Enlightenment was nowhere near a biblical movement. The Enlightenment was as far away from the Bible as you could get. Its goals were to question everything concerning the Bible, and not informative questions. You've all raised children, and Vicki and I went through this with our kids. There are two types of questions you can ask. One are the informative questions, and Mom and Dad get that. We understand that. And then there are the challenging questions, and we can see pretty clearly which ones you're doing. And so the Enlightenment were the challenging type questions, and ridiculing everything the church did and the scriptures. It was just not something that they wanted to embrace and see any more influence in the European culture initially. But James Hutton was one of the fathers of the Scottish Enlightenment. He was not a geologist, he was a physician. He just enjoyed traipsing around the rocks on one of the beaches there in Scotland. And so he's credited with developing the idea of uniformitarianism. It had to do with uniform geological processes and rates over millions of years old. In fact, he's famous for saying the earth has got to be older than what the Bible says, for it looks older. And I'd say that was really an enlightening scientific concept. It's older because it looks older. Well, that's not a very good scientific conclusion. I think it takes a little bit more than that. But Charles Lyell then took up his ideas, and with his 3-volume book on principles of geology, he set about changing everything in the culture as it had to do with geology. even was credited with converting several college professors from Cambridge and a few other places that were notable Christian in their perspective when it came to the Scriptures. But Charles Lyell was an attorney. He was not a geologist. He was an attorney. And as such, these two men were educated, and they were educated in an Enlightenment view of culture and humanity. Now, that set the stage for modern geology. That's why we have the division we have today. That's why we have the whole conflict. You've ever heard of it, science versus the Bible. You hear it all the time. Where did it come from? Not because there were people sharp in investigation. It was because of the Enlightenment. The Enlightenment put this chasm there between scientific thinking and the Bible. And it's really a straw man. It's just a false concept. So, in 1972, I started to read the Bible for the first time in my life. Now, I was like so many before then. I would ridicule stories that I'd heard, namely Noah's flood. You know, Noah trying to cram all these animals on the boat. What a joke. Yeah, that was my impression of it. But I'd never read the Bible for myself. I'd heard parts here and there going to church and stuff, but never read it. And so I became a Christian in 1972, and I was challenged to know what the Scriptures had to say. And of course, as I sat down to read the Scriptures, it became very clear to me, wow, this doesn't take a doctorate degree to figure out what the Bible is saying. It's a straightforward reading, tells me that the earth was created in 6 days with a day of rest. And in about 1,600 years after that, a flood came on the earth, a global flood. Now, when I read that part as a geologist, Genesis 7 and 8, talking about the global flood, that really caught my attention. Because I was used to thinking in geological terms. And so, Genesis 7:11, fountains of the great deep, first day of the flood, fountains of the great deep burst open. What do you think's going through my mind as a geologist? Well, I'll tell you what's going through it. Tremendous earthquakes, earth shifting, earth breaking up, crust of the earth shifting, water pouring out, heat involved, massive amounts of lava and magma. All of that ran through my mind as I read that. And I thought, whoa, this is geology it's talking about. This is the study of the earth. What I'm reading right here is the study of the earth. And what this did was cause me to question some of the things that I was learning in geology. One of the main questions was this one: how much of these geological processes that I'm taught, small and slow and long ago, how many of these processes have geologists actually observed? That's a good question, isn't it? Has anybody ever seen rocks like granite form? No geologist has ever witnessed granite forming. Did you guys know that? I was just blown away. I'd never thought about that before. No one's ever done it. No one's ever performed the idea in the laboratory even. We can melt granite, and it's got the same minerals as the rhyolite lava, light-colored lava. And every time we melt granite, we get rhyolite lava. But when you melt rhyolite lava, you get more rhyolite lava. So we can't figure out how to make granite. To my knowledge, to this day, no one has ever produced a study or investigative research on how to make granite. It's just, it's one of those mysteries. The other rock that geologists have not seen form is gneiss. It's a metamorphic rock. Notice it's a characteristic alternating light and dark bands of minerals. No one's ever seen that form. Now, we have seen volcanic rocks form to a certain degree. All you need to do is go onto YouTube and type in Kilauea and see some of the recent lava flows and eruptions. You can watch lava harden even. It doesn't take very much time. Lava quickly turns to stone. We went to a demonstration at one of the museums there on Oahu one year. And at the museum, they were talking about the volcanic nature of the islands. And they had this big kiln going. They fired it up right at the beginning of the talk. They were getting the temperature to about 1900 degrees, which is the rough temperature of basalt lava. And at a certain point in the lecture, she turns the big kiln over and out pours this lava, red hot lava. And it hit the screen, and then she picked up an iron rod and poked it, and it went clink, clink, clink. So it was that fast. Now, it was still hot, but it cooled very, very quickly into a volcanic rock. So we have seen volcanic rocks form, and it doesn't take much time at all. Now, this is another real mystery, and that is sedimentary rocks. We can make concrete, which is a type of conglomerate, really, man-made, but that doesn't take much time at all to produce concrete. We can harden it with certain chemicals, using the same chemicals that we find in limestone, some of these others. But the petrification of plants and animals is really not something that practically has been seen very much at all. Some of the examples of that would be Yellowstone. How many of you are old enough to remember bobby socks? Some of you remember bobby socks, the white socks? Well, a lot of the trees in Yellowstone, when they're encroached on by spreading hot spring water that's rich in silica type of quartz, the trees initially suck that up, and then it hardens. And that is about as close to petrification as you can get. And those are all over Yellowstone. The other thing is incrustation. So there are animals that fall into these things, and silica and the travertine, whatever else, can encrust and very rapidly does so. And it slows down the rate of decomposition. But the massive amount of fossils that we have all over the world today, it just kind of defies a naturalistic explanation or a small and slow and long ago. It just doesn't happen on a day-to-day basis, only under unusual situations. So here I was asking these questions. Well, if what geologists were telling me was true, the first thing I had to come to grips with was that my Bible was full of beans. If geologists are right about the age of the earth, if geologists are right about the millions of years it takes to form these rocks, then my Bible is worthless because it doesn't come close to communicating that kind of an idea as you read it. And it would make Jesus irrelevant. Jesus referred to Noah and the flood. He referred to Adam and Eve. And if geologists are right, then Jesus is just using myth to teach supposedly eternal spiritual lessons. Well, this can't be. Either one is right and the other one is wrong, or vice versa. You can't meet in the middle somewhere. Either the Bible is all right, or it's all wrong, or at least all suspect. And you can't build an eternity on that kind of a level of confidence. You just can't. It won't work. You don't have any promises. Where are the promises? It's like being told, when you're a little kid, that Santa Claus is going to bring you a lot of presents for Christmas. And lo and behold, you find out it's really mom and dad coming home from the the 5 and dime store with all your gifts, that just knocks the socks off you. And so it's a little bit like that. We find out that, wow, what we're reading about here is really, it's either got to change in some way, but it really doesn't mean what it says. I don't see how you can build faith on that. Your faith is really on a pile of sand in that case. A typical modern earth science course, whether it's 4th grade, 8th grade, or in college, involves 2 aspects of discipline. One aspect is science, and the other aspect is history. Earth science and earth history, by the way, are 2 completely different subjects. They really should not even be taught in the same school. Historical science has nothing to do with science at all. It is a department of either philosophy or history. When you study the science, you do just like what I did when I opened up. We were looking at what we could observe about the rocks. I'll get into a little bit more detail about that. But science and history are 2 completely different subjects, and they need to be understood as such. And this is, I think, part of the problem the church has today, not being critical in their thinking, separating those 2 areas of discipline. But at any rate, we teach those as one combined unit in school-age kids. And so scientists say this, they must be right, and they also say the earth is 4.6 billion years old. So if they're right here, they got to be right here. And that throws a wrench into your faith. And if you don't get it resolved, it's going to plague you until you do, or you just ignore it. So, what is science? Well, science is what can be observed, tested, and repeated. The word comes from a Latin word for knowledge. It's very interesting. In the 1800s, the scientists, the geologists, chose to exchange different words. They were using Greek words, they were using Latin words, and a lot of Greek words are used in geology. Geology is an example, study of the earth, it's a Greek word. But when it came to science, they opted for a different word. Now, I don't know why they did it, but I can suspect why they did it. They chose the Latin word for science because the Greek word for knowledge, Latin word for science is knowledge. The Greek word gnosis is the word for knowledge. The Greek word implied a theistic understanding of knowledge. Knowledge in the Bible is something God has revealed, and we are supposed to learn it, and we're expected to learn it. But in scientific circles, the word was exchanged for the Latin word, science. And it was knowledge gained by human understanding and human reasoning. So it pitted 2 completely different forms of knowledge when, in fact, both of them meant the same thing. Science, Latin, was just simply the word, same word that the Greeks used, only it was just a different language. But it became its own separate field. And so when you talk about science today, you're talking about what brilliant men have discovered through experimentation and reasoning and so on. And when you study biblical knowledge, well, that's myth. That's something else. But you see how things have gotten turned around in less than 150 years. So twisted that our culture now relies upon scientists and hangs on every word they say. It's very interesting. I've listened to this. I'm just this kind of a person. I sit down, listen to news. So when they're talking, the news people bring in some special guest. And it usually is Professor so-and-so from the University of such and such. That gives everything that's going to be said and discussed credibility at that point. And that's what's formed our culture. And it's a devastating thing that's happening, and it really attacks our faith. So science is what can be observed, tested, and repeated. Well, what is history? History deals with one-time, unique events, and it's based on eyewitnesses and historical records. Now, if you just think about these two, already I think you could probably see that, whoa, these two are completely different disciplines, and they need to be studied as such. So now we get into two other words that are rarely discussed when it comes to especially geology. You know, when I studied geology, it occurred to me after a while that, well, about 80% of what I'm studying has nothing to do with science at all. It has to do with ideas from different people as they've studied different things. It has to do more with ideas than it does actual science. Philosophy deals with interpretations and biases. Another word we often overlook is the word consensus. This is a very powerful tool in our culture today. It's based on group agreement, often regardless of what the facts are. You know, you learn this when somebody says, you know, you are an idiot. All sane scientists believe that the earth is 4.6 billion years old. And it's an intimidating thing to be told that, because you're this lone science denier out here. But I have to come back and say, well, wait a minute, that may be true. Every scientist and their pet may believe that the earth is 4.6 billion years old. That does not make it fact. It doesn't make it right. It doesn't make it true. It makes it consensus. And many scientists, they'll agree that this goes on. They'll agree that it's very important that we watch what we do when we formulate ideas, that we don't involve interpretations and biases. But it happens all the time. And many times, scientists are not aware they're doing it. And this clouds the whole thing. You can see now why we need to build into our kids a spirit of critical thinking when it comes to deciding and discerning science, history, philosophy, consensus. Now, today, science has kind of become whatever scientists agree it is. I really learned this when I was a kid, doing all of this fossil hunting out in Montana. Boy, everywhere you looked, and you just drive out of town a few miles and you start picking up fossils. And so I would collect these fossils, dinosaur bones, things like this, and I'd learn the names, I'd learn the ages, learn the species, the genre, and so on, of these various creatures. And then 15 years later, the entire scenario would change. So that, for instance, Triceratops, one of my favorite dinosaurs as a kid, was taught that there were roughly 21 different species of Triceratops. It gives the illusion that evolution has taken place. But today, there are about 2 Triceratops that are considered individual species. All the rest of them are considered variations, whether they are due to maturity, whether it's due to old age, developing skulls, things like this. Very much the same way we see ourselves changing. I've lost an inch off my height because of age. Some of us are getting stooped in the way we walk, or arthritis. I have arthritis real bad. That is part of aging. And so if somebody were to find my skeleton, unless they were familiar with the human race, they would draw the conclusion that perhaps I was one of these evolutionary anomalies, that it was a species that went extinct. So this goes on, though. Why? Because a lot of it is not science. We know very little about the rocks and dinosaurs today. Very little. And primarily because we can't observe their origin and their formation, their habits, things like this. So maybe what I concluded when I was a senior was perhaps what we're dealing with is a war over ideas, not science at all. And this whole challenge of science versus the Bible was simply a straw man. It really had nothing to do with reality. Nobody disagrees with actual science. Science, again, things that can be observed, tested, and repeated. When I had my hips replaced, what did I do? I did a very scientific thing. I did a lot of calling around, asking questions. I wanted to find out, in my understanding, the best surgeon who could get the job done. I didn't want some student replacing my hips. No, thank you. I wanted the guy who really was, okay, he's the go-to guy for hips. Okay, good. Okay, that answers my question. So we do that based on science, and no one disagrees with it. But we've been led to believe that the Bible is not scientific textbook, and so therefore it really is irrelevant to discussion of science and origins and so on. Well, no, it's far from the truth. It is true that most scientists either deny or ignore the Bible today in any discussion about origins. I mean, that's true. It's different degrees of it. They will tell you the Bible is myth, it's misunderstood, or it's irrelevant. And by the way, we do things according to science, not belief. Now, that really puts a damper on your faith, doesn't it? Wow, I'm just believing, kind of a mind over matter here. It's really not scientific. And it stumbles your faith. Except in the subject of origins. I don't know how many things you've read, like on the Big Bang or history of the Earth, things like that, where they'll bring up the latest research and then they'll say, scientists believe, or Dr. So-and-so believes. How many times do they bring in the word belief in formulating the ideas about the Big Bang? It permeates the literature, and nobody has a problem with it. But let a Christian say what we believe, oh, wait, no, that's faith, that's not science. Well, I'm sorry, but you do it. You do it all the time. So let's take a look here. When we say science is what can be observed, tested, and repeated, well, neither the Big Bang nor biblical creation are science according to that definition. No one's been able to see these actual events happen. These are one-time, unique events. The subject of origins, therefore, is really outside the realm of science. And that's true. This origin of rocks is outside the realm of science, with the exception of observing modern volcanic rocks. It's outside the realm of science. Now, but look at the second one. History is based on eyewitnesses and historical records. Now, scientists claim that the Big Bang is history. This is the history of the universe. The Bible, though, actually qualifies as history. Why? Because it's a record of historical events with eyewitnesses. Who saw the flood? Noah and his family. This other one, too, I like to think about. Jesus talks about the creation. He not only saw it, he was involved in it. In the beginning was the Word. The Word was with God. The Word was God. All things came into being through him, and apart from him, nothing has come into being that has come into being. Ooh, you talk about an eyewitness. He's a pretty strong eyewitness. He was actually involved in the creation. And here he shows up in Bethlehem several thousand years later. The Word. I like to think about the intelligent design movement. They talk about the intelligence. I know, wow, the intelligence they're looking for is the Word, the Logos, the intelligence that gave the universe meaning and purpose. It's the Word, Jesus. He's right there. It's just right in front of our eyes. So, how would you classify then the Big Bang? Well, it's really philosophy. It's a set of interpretations. It's man's ideas. That's fine. You're welcome to your ideas. Just clarify it for me, would you? It's also consensus, group agreement. So, okay, smarty pants, then just where does the Bible talk about or discuss rock types? That's a very good question. You don't turn to the Bible to pull out your manual on rock identification. Those names came later. But let me provide something for you to think about. First of all, we're going to regroup the rock types. Scientists today group rock types based upon how they think they were formed. We're going to organize them around what they look like. And I think this will help clarify the picture. For instance, let's take these two rocks here. These are what we call coarse-grained rocks. Doesn't mean they're rough or smooth. It's the fact that you can see the minerals. There's a close-up of one of them down there. All those things in there that you can visibly see, those are the minerals. And so that's what we call a coarse-grained rock. They can be darker, they can be lighter, as you see here. Scientists call these rocks Plutonic Rocks. It's from the god of the underworld, Pluto. And it's really the name for the foundational rocks of the earth. And as a matter of fact, granite, the top picture there, is the continental, or the rock of the continental crust. So it forms a foundation. And but we're going to group this as a separate rock type. These are the Plutonic rocks. When you go back to the table there, and for those of you who are watching this live, when you go onto our website, I have several presentations on rock identification, and you can view those and see a lot of examples and samples of this. But back there on the table, if you want to look at these as we close, you can see what I'm talking about here. This is really quite uniform. Now, the colors do vary, but you can see the minerals. That's the one thing about Plutonic rocks. Well, let's go to the second type then of rock. These, you can see dark and light colored rocks. These are what we call fine-grained rocks, or the volcanic rocks. These are the true igneous rocks. And these are rocks in which you cannot see the minerals in the rock. You see a general color, but you can't really make out the minerals. You just know that the basalt, the darker lava, is made of darker colored minerals. You just can't see them. And the lighter colored lava is a rhyolite lava, and it's made of lighter colored minerals. Same as the Plutonic. So these are the fine-grained rocks, or the true igneous rocks. Why do I say that? Because we can actually observe some of these forming even today. And they all form the same way. They're fine-grained rocks. So a third type of rock are rocks that look like this. These are rocks that they kind of look a mess. They're all over the place. There's no real definitive structure to them. They just look like they've gone through some kind of change, and indeed, we call these metamorphic. They have the appearance of change. In other words, the minerals have been reorganized or crystallized into something. Now again, that's just an observation. It has nothing to do with their origin. It has to do with what they look like. And fourth type of rock are these types of rocks. They're sedimentary, and they deal with an accumulation of different sized sediments and chemicals, often containing fossils. So here you can see the work of lots of fossils that were buried in limestone on the upper picture. The picture below has to do with a type of limestone called Travertine, but its development is influenced by cyanobacteria. Isn't that interesting? And so you get some of the crazy designs in it. It's really a very pretty. Some of you might even have Travertine in your home. It makes an excellent flooring, but you got to be careful with it though, because it does react to things like vinegar and lemon juice and stuff like that. And it's very destructive to travertine. But sedimentary rocks are what they look. You can also see that these are earth tone in their colors. So you get an earth tone rock that has fossils in it or some kind of sediment accumulation, whether it's coarse or fine. You're pretty sure you've got a sedimentary rock. Now, I've described these 4 rock types without referring to their origin. It's just simply what they look like. This is one of the things I think it's crucial for our kids to learn. How to observe and record observations as opposed to conclusions. This is a very big part of science that's left out of their education today. They are told what to believe. And then they're told how to believe it. And if you pass the test, you can move on. If you don't, you stay in the group until you get it right. But the kids never learn how to think. And they certainly don't want to challenge it. Like, my goodness, you don't challenge that. You accept it, and then you move on. But that's the way our whole education system works. Now, part of our job as biblical apologists is to help distinguish the difference between what is observed and what is interpreted. And I think once you start to get that habit down, you pick up very quickly when it is you're moving into the realm of interpretation, personal ideas, and moving beyond observation. And that is a place we need to be and a place where we need to see our kids get. So let's look at the origin of the rock types now. Laid a big groundwork here for talking about the origin of the rock types, but you can see it's necessary. It's how far we've gotten away from what we're supposed to be doing. So, science is what can be observed, tested, and repeated. Since most of the rocks have not been observed forming, we must use a different framework to interpret their origin. You can't use science. It's beyond testing and observation. You can't do it. So you've got to use a different discipline. Well, let's use then the discipline of history. And the Bible has given us a very detailed historical framework for interpreting Earth history. Here it is. You are welcome to copy this if you like. It's a historical framework for interpretation. Now look, all I've done is take the 4 basic major events in Earth history as they apply to geology. There's actually a 5th one, but I leave that off for now, and that is when the Earth changes geologically in the future. The elements will melt with intense heat. And the stars, the universe will disappear with a roar. That's a geological statement. And that's also big and fast, but it's in the future. And so that's a 5th element of geology that I'm working on presenting. But here we've got 4 elements here. The creation, 6-day creation, 7th day of rest, a pre-flood world in which corruption really soiled and spoiled everything about what God had done. Lasted about 1,600 years. This is where you get into the patriarchs of Genesis 5. Every one of them that came from Adam by way of Seth. are listed there in Genesis 5. And you can figure up the exact number of years between Adam and the flood. And then there's the flood, and the flood is divided in the Bible into 2 geological periods. The inundation, when the earth was covered with water, and then the recession, where the water came off of the earth. Both of those are geological presentations, and we should learn them as such. What does that mean to have rushing water, a huge amount of rushing water, go over sediments? What would that do to them? Well, good illustration is the Grand Canyon. My goodness, there was an awful lot of water that came through there. And then the post-flood period. Which period are we in? We're in the post-flood period. And when you think about the post-flood period, the last 4,500 years, that explains a lot of why we're going through some very dynamic changes within our climates, changing all the time. Some of it's very drastic. Is going through extinctions. You think about the extinction that happened in the flood, and then you can think about the extinctions that have happened since the flood. There have been a lot of animals disappear since the flood. So this is our interpretation. So now we take granite, or the Plutonic Rocks. Plutonic rocks have not been seen to be forming. So perhaps what we're looking at are foundation rocks that were created on the first day of creation, covered by water. The earth was covered in water, and land appeared after that. He parted the water, and land appeared. So perhaps we're dealing with that. And granite makes a nice foundation rock. Very, very tough. What about the volcanic rocks? Well, the volcanic rocks, I'm fairly convinced that these really had their origin at the beginning, at the initial part of the flood. Here's why. Volcanoes and volcanic rocks, gases, and so on are very destructive to humanity and to the biosphere. You can change a lot of things by shoving a lot of sulfuric acid into the atmosphere. And, we deal with this concept of acid rain, things like that. Well, you're talking about a lot of acid rain in view of a volcanic eruption. The gases are very poisonous. In Yellowstone, there are signs, sometimes people don't see them, but they warn you. If you begin to feel lightheaded, leave the area immediately. Why? Because you're dealing with carbon dioxide and with hydrogen sulfide gas. These things will kill you. And so I think these really came about not as a part of the creation. Because by the end of the creation, it says God looked at all that he had made, including the volcanic poisonous gases and the hot lavas that were moving over everything and destroying all of the biosphere, and said, it is very good. I just can't, it doesn't fit within my theology. It just won't fit. So I really think that when the fountains of the great deep burst open, it released all kinds of garbage that was under the crust of the earth. Volcanoes today are a reminder of just how weak our earth is, how precarious our lives are. We live in an area here that we don't think much about these volcanoes. They don't erupt every day. But all it takes is one big lahar or landslide coming down Mount Rainier, and you can wipe out fairly quickly about 250,000 people. It doesn't take much to do it. So volcanic rocks, then, are the true igneous rocks, and they were formed starting on the first day of the flood, and we have them ongoing today. It's a natural part of a very corrupted and a volatile earth because of the flood. Well, what about these metamorphic rocks? Let's look at them here. We've got rocks where obviously the minerals have been reoriented. The top picture there is nice, and it's the same minerals that's in granite. It's just the minerals have been realigned. So you've got alternating light, dark, light, dark, light, dark minerals. And then the one on the bottom is marble. It's a crystallized form of limestone. It will respond the same way as limestone does to acid. So what about these rocks? Well, if you think about the flood again, first day of the flood, fountains of the great deep burst open. Now, geologically, I think, wow, what is that going to do to the crust? Huge amounts of crust are going to shift. Some are going to disappear. Others, in their shifting, are going to grind against each other. Now you've got friction and a lot of heat. And heat changes things very rapidly. We do this when we cook, don't we? Don't we change things chemically because of heat? Everything changes. I wouldn't eat my wife's brownies out of the pan before they were done. I'd want the heat to take effect and cook them, change them chemically. Eggs change chemically as we cook them. And so I think what you're doing with metamorphic rocks is you're changing pre-existing rocks in some way, whether it's recrystallizing them, crystallizing them, or reorienting the minerals and turning them into something else. Now, no one ever saw that. I never saw that. But it's, again, noticing that I am interpreting what I see based upon a historical framework, a biblical historical framework, one that's been revealed to us. That's pretty safe to develop your ideas within. If you leave the framework and you start coming up with all these wild ideas, aliens populating our planet, well, it's possible, Yeah, well, it doesn't fit our biblical framework, though. When you leave the biblical framework, you're going to get into trouble. Stay within the biblical framework and develop ideas that are worth discussing. This is where we have got to get. So metamorphic rocks, changed rocks due to heat and pressure, and there was a lot of it at the flood. I have some rock that comes from the San Andreas Fault. It's called fault gouge. It's actually clay that's been partially metamorphosed into a very soft rock. Very interesting stuff, but it's because of the shifting of rock along the San Andreas Fault. That's a very, very interesting thing to think about. So metamorphic rocks formed as sediments and plutonic rocks that ground against each other during those first several days and months of the flood. A lot of it was going on, a lot of shifting. What about sedimentary rocks? Sedimentary rocks cover 70% of the Earth's surface. So that's a lot of sedimentary rock. Here you can see this is a mountain of shale that you're looking at here. It's near Anaconda, Montana. It's layers and layers and layers and layers of shale, which is a sedimentary rock. Notice that the color is an earth tone color, so you can pretty much see this right away. Sedimentary rocks formed as sediments, and billions of dead things were buried by these flood waters. Flood waters covered all of what were then the highest mountains by at least 15 cubits. And so everything was inundated and destroyed, and then reshuffled again as the mountains rose, according to Psalm 104, verses 5 through 9. The mountains rose, the valleys sank down. Now you're talking about a lot more volcanism and a lot more ruination from flooding waters that were now receding. I think it was during this period that Yellowstone erupted. Yellowstone doesn't show any sign of having erupted underwater, but it was one of the biggest eruptions seemingly in Earth history that most likely took place at the end stages of the flood, and helped even bring on this thing called this ice age that we talk about. So not only is there lots of sedimentary rock here that was churned up by the flood and laid down, quickly hardened, big and fast in the recent past, but billions of dead things were buried. Now, this one is a very interesting piece of limestone. This comes from a much, much bigger piece. I left the tape measure in there just so you could see. You're dealing with a foot by almost a foot of limestone. I've got several. I got a whole box full of this stuff. And the fossils in it are thousands of fossils that were buried at the same time. This comes from a formation that's many, many square miles in this kind of stuff, and very, very thick. So this is not something that happened small and slow and long ago. It had to have happened big and fast in the recent past. So these four rock types then, as we look at the origin, we use a different framework other than science. We use our historical framework. Big and fast in the recent past, not because of the science, but because of the history. The Bible is a history book after all. It's not a science textbook. We're left to discover and observe what God has already done. That's what we're told in Romans 1. It is a history textbook, which gives us a framework to interpret what we see around us. So, to close off here, we can summarize this. Most of the rock types were as a result of the Genesis flood. See how big of an event this is, and why I spend so much time teaching on the flood is a pivotal point in Earth history. Everything changed on that first day. Massive cracking of the Earth's crust, releasing untold volumes of magma and lava. Unprecedented earthquakes producing huge amounts of metamorphic rock changes. Global catastrophic flooding bearing layer upon layer of sedimentary rocks and fossils. It really does fit very, very well with between what we see and our biblical view of Earth history. So, we should probably go ahead. I look over at the clock here. Sometimes time really does get away from you, doesn't it? So I'll go ahead and close off in prayer. And then if you want to ask me any questions later, I'd feel free to do that. Let's do that. Lord, we thank you for the revelation you've given us in the Scriptures. We thank you for just the truth that it holds and the knowledge that it gives us, so that we don't wander around thinking lame things and things that are just don't make any sense. But Lord, you've given us solid footing by giving us a Scripture. We pray that we would learn it and teach it, and especially our young people. You'd show us how to equip them to be confident in the Scriptures. Amen.